All right, I guess I can start now. Perfect. Thanks everyone. I hope you had a great day in Droidcon, Italy. It was a lot of fun talks, so why not finish it with another one? So again, thank you so much for joining me on this journey of jumping to another world using Kotlin multi-platform. Before we get to know each other a little bit more, I would like to say a self-disclaimer. Pregnant women, people with a heart disease, and another chronic diseases, I highly suggest you jump off right now from your live streams because jumping to different roles can be dangerous. And definitely consult with your doctor before watching this talk. Jokes aside, let's get to know me a little bit more. So I'm Seyed Jafari, and I'm a software engineer at Revolut Ltd. And you can check out my Rusty blog at worldsnest.com or reach out to me with your questions or your fun topics at Twitter or LinkedIn, literally anywhere else. With that said, let's dive right into it. So what is KMP? First and foremost, KMP is short for Kotlin Multi-Platform, and it's a technology that allows us to compile our code for different platforms. Now the question arises, okay, what is a platform? So a platform is a system that runs your compiled code. Simple as that. But then you might have heard it already, and you might already think that I'm jumping between semantics a lot here. But trust me, these are the only semantics you need to know. And Kotlin backend is the last one. So what is a Kotlin backend? It's a compiler that compiles your Kotlin code for a specific platform. We have different Kotlin backends for obviously different platforms. So we have Kotlin native, which compiles your code for Windows, for Mac OS, for Linux. And again, of course, we have Kotlin JVM, which all of us Android developers must be already familiar with. And the next one is Kotlin JS, which compiles your code or technically translates your code into JavaScript for web and Node.js. As you can see that KMP can kind of translate or interpret or compile your code for different platforms and run it on those platforms. But this is not the single technology. There are other technologies out there. And right off the bat, I want to tackle and do a little bit of comparison between them. So let's get to know them. Flutter is the first one with Dart language. The next one is React Native with JavaScript, and Xamarin with C# language. And if you're old enough, you might probably know about Cordova, but I really hope you don't know anything about it because, whew, yeah. All right. So now we know KMP is not alone in this market. There are other the competition is pretty high, and everyone is trying to make a name for themselves. But what makes KMP stand out from this crowd? For me, the first and foremost is Kotlin language. I really like to work with Kotlin language, and it makes developing and day-to-day experience a phenomenal comparing to other languages. And talking about languages, it's worth mentioning that people have the idea of Dart, which is the language for Flutter, shouldn't even exist as the language. And also JavaScript, it has not a good history of being an easy and straightforward language. So it's very challenging. And C#, I mean, for Xamarin, who really wants to code a mobile application using C#, right? So Kotlin is definitely has the advantage here. The next one is interoperability and no bridges. Unlike the other technologies that I showed you, Kotlin multi-platform doesn't need a bridge or interoperability. And it basically runs on that system natively without any bridge. It's directly running on the system. With that, as a side effect of that, you get the native performance as opposed to, let's say, React Native, which has to run through a bridge of JavaScript, and then JavaScript engine runs your code on the system. No, your code runs native on the system. The next one is the focus of KMP is mainly business logic, as opposed to the Flutter and React Native, which suggests and tries to push for the entire application to be shared. So you share your UI, you share your business logic, you share your network layer. But with KMP, right now, the focus is mainly on the business logic, which again can be beneficial. We can see that in a bit. And the next one is platform support. Again, I showed you already that a lot of platforms are already supported, but when you compare KMP with Flutter and React Native, you still see that KMP can support many more platforms than the other two. All right. So you might have already heard about KMP, and you say that, okay, I don't have to really care about it. It's just another technology. It's going to be around for some time. It's going to be gone by the time that I get to know it. Even though that might be true, because every technology comes and goes one day, but I suggest that you should care. But before I answer why you should actually care, I'm going to take you through on how we can set up, use, and build the multi-platform project using KMP. And then after that, I'll go back to this question and answer your question of why should you even care, right? And I see that everyone agrees, so let's do it. Since we are in Droidcon and everyone talks Android, bleeds Android, and eats Android, I have prepared an Android project structure to take an example from now on. So usually in an Android project structure, you have an app module that technically builds the entire application. And if you're not modularized, then the whole code will live inside this module. And you have a build.gradle, which most of the time looks something very similar to this. On the top, you have plugins, Android configuration block, and at the bottom, you define your dependencies. Nothing super science fiction, right? And now we want to enter and see how a KMP project structure looks like. So first, we need to add another module. We create a new module, and this is not a special module. We just see it for ourselves right now in short. And we have to add a dependency to that module in our app module, simply because we want to tell the app module that, hey, some of my code lives in that module. Simple as that. So that's the only change we need to apply on our app module. And then the next one, let's see how does that shared module that I added looks like. So first thing, when we open it, we see that we have 3 source sets, and instead of 1, we usually just have main and then everything goes inside. But here you can see we have Android main, common main, and main. I'm going to ask you to forget about main for now here, but and the main focus is going to be our common and Android. Again, we will discuss the source sets in much more details, but for now, let's look at the build.gradle and see how it looks like. So if you can see from the top, a quick scan doesn't give you much, but it gives me an idea. It's not very much different from what we had in app module. But to break it down, so on the top again, we have applied 2 plugins. The first one, of course, because we want to go on KMP, so we need the Kotlin multi-platform plugin and the Android library, because the module has to serve as an Android library or Android module. And then on the next block, we'll configure our Android library the way we like it. This is totally optional and depending on your project, and doesn't have to do anything with the multi-platform. The next, which is the interesting part, is the Kotlin multi-platform or KMP from now on configuration block. So immediately right off the bat in the configuration block, you can see that I have enabled Android target in the configuration block. So I added the function called Android, and with that I enabled target. So I'm talking about targets now, and you might think that, okay, there is a new term called target, but we don't know about it. don't freak out. Target is not a new thing or a completely new idea. It's just another way of saying platform, but to be a bit more precise, and we will see that again shortly. So whenever I say target, just imagine that I'm talking about platforms. So again, with Android function, we just enable Android target, and in the source set, we just talk about, all right, which source set we're gonna have in our module that needs to be built at the compile time. So of course, we have the common main, which all the shared code and the code that we want to share with other platforms or targets will live in, and the Android specific source set, which is only designed for Android code and only. All right, so now if we go back to here, you can see that the Android main and the common main makes more sense. And you can see that it relates to what we had in our build.gradle. But what if we want to add another target? How should we do it? Since we are mobile developers, I decided, okay, why not to add another iOS target, right? What's even cooler? So again, it's not going to be super different. It's just we will add another function in our config block, iOS. That's it. It enables our module to be built for iOS platform or target. And then in the source set, we have to define which source set we're going to use for the iOS code. In this case, iOS main is going to be our source set. Now, if you go back to our source sets, we can see that I added iOS main and classes and the packages to our module. So this is as simple as you saw. So adding a new target, adding a new platform is just configuring it, adding the function in the configuration block, adding the even an empty source of the directory here, and you're good to go. But I kind of cheated here because iOS by itself is not a target, and that's the difference of target and platform comes into play. Platform means the entire iOS platform, and what I did here is that added iOS, all of iOS targets to the compile time. So basically, this iOS function is a convenience method. It's a handy function for adding two targets at the same time. So we add iOS x64 and iOS ARM64, which are different targets for different CPU architectures of iOS. And if you want to add them separately, we can add their source sets, and we can add their code separately as well. But about coding, we'll get into that later. So you can see you can also add them separately and code specifically for that architecture of your choice. You don't have to share your code for the entire iOS architectures. And if you go back again to our source set, we can see that I added remove the iOS main source set, and then instead added iOS ARM64 and iOS x64 as my sources. But if I cheated and instead of one function added two function, how did iOS function work at all? How did we use the iOS and still manage to build our project while the real targets were something different, even though we had code in iOS main source set? The secret or the magic lies behind the hierarchical project structure. So KMP has a feature that allows you to build your code in a hierarchy, so you don't have to break your code into very small pieces. Rather, you can actually share as much as possible. What I mean by that is that most of your shared code will live in common main, as I've just said it, and then if that code is iOS specific, fine, you can add it to iOS iOS main source set, which will build and compile that piece of code into for both of the iOS architectures, again ARM64 and x64. But if you want to If you don't want to share the code for those architectures, then you can actually pick those source sets and write your code in those source sets as well. So you can see that the hierarchy starts from top, the common main, and then it goes to iOS main and goes to CPU architecture specific source sets. So with that said, we can obviously see that we can add back the iOS platform or target and have it source set in our module. But iOS is not the only hierarchy that we can benefit from. There is a bunch of other ones. So if again on the top we can go with common and then divided by concurrent. On the other side we have JS. So you can see the hierarchy is not just limited to iOS, but we can benefit in other ways from it. So if you have a native code that can be run on all of the native platforms or targets, then you can by all means write your native code in native main. So it leaves your hand wide open on which part of the code can be shared, which part has to be rewritten for every architecture. And if you're interested to see a list of all the targets that are supported, the list it can be even longer than this because they are adding in more and more targets. But here's what I found on the plugin. So JS, JVM, Android, iOS, and Apple targets, as well as Linux and Windows and WebAssembly. All right, so with we have our code set up right now, and the entire building and tooling is already set up. Now it's time to see how we can actually share or code in a shared way. So as I said, if you want to share our code, I mean, by default, everyone wants to share the maximum. So I would push for putting as much code as possible into common main, right? So from now on, I'm just going to talk about common main, and the iOS specific details will not come in handy here. So here I added a small class called greetings. And in that greetings, I have a small function, very simple, that prints hello or returns hello and the name of the platform. If you call this function, what you will see in the console or in the UI is hello from Android or hello from iOS. But how does it actually work? Because we are in a common world, we have no notion of where am I running, because I'm in a shared land, I'm in a shared space. I don't know which specific space I'm running. I'm running. So all I know is that I have to run this code, and that's it. So where is the magic happening? It's not super crazy. Let's see it together. Here you can see that I have another class called platform, and all the magic is happening inside it. And when you open it, it's empty. Exactly. So it's a normal class with a normal property platform, and that's it. And you can get the property, create the class, get the property, and that's it. But the only difference is the expect keyword, which is the prefix of our class. So what the heck is this expect? Expect is the opposite of actual, is the KMP way of saying, listen, shared code, I'm going to define a class here, a class signature, or any kind of a function, class, variable signature here. But the definition is the actual definition will live in different platform specific source set. So in our case, we had a expected platform class. Intuitively, we should look for the actual implementation of that class, right? So the first thing, first place we jump to is Android main, because there should be implementation in the Android main. Actually, KMP forces you to implement it. And as you can see, that there is actually a platform class in the Android main. And when you open it, again, there is nothing crazy. Same class, same parameter inside it, only it's been prefixed with the actual keyword telling the KMP that, hey, remember that class was signed in the common code? Here is the real definition. Whenever they use it over there, just provide them this implementation. Simple as that. So when it's compiled, it's not going to be a double code. No, it's just going to replace that code for that specific platform. And for the iOS, we can also see it, same project structure, same packaging. It has to be exactly in this way. And then easily just implement the code with the actual prefix keyword and return the string. And right now, it might actually occur to you, okay, but we already have interfaces. We can have an interface and define it into different implementation. That is completely right, except with interfaces, there is no state. You cannot create an interface. You have to create the object that implements the interface. That is the difference of actual and expect with interfaces. With actual and expect, in the common code, you can actually create a new object of the platform class, even though the implementation is not there. But with interfaces, you can only do it with a real concrete implementation. So just bear in mind when you want to deal with the expect and actual and interfaces, they are different. All right, so we saw that the common code is so cool. So we want to push all of our code to the common main source set, and let's share as much as possible. But I'm gonna tell you, hang on for a moment, because you're gonna be disappointed. The moment that you enter the common code or a common main source set, you're not gonna find anything useful because there is nothing in there. There is no database. There is no string manipulation. Yes, I'm talking about that string that replace or those functions. And there is no serialization and deserialization in that code, in sharing code. No threading, goodbye to our beloved ArcsJava. No file IO, no UI framework. I mean, why would you even need it? Because as I said, KMP is focused on business logic sharing instead of UI, but not even networking. So you cannot fire a network request from a common code. Sorry, not that one. And last but not least, which blew my mind at first, was date and time. So yeah, there is no notion of time in the common code. But that's not the end of the story, because a lot of these wheels already exist. Some of our best friends, our comrades, already provided a library that cover these use cases. So for database, although there is nothing native, there is a library for it. So you can use SQLite or Realm. Or for string manipulation, thanks to JetBrains, they provided all of those functionality in the Kotlin language, so you don't have to import another library for it. And for all of them, for the rest of them, you have for serialization, you can use Kotlin serialization, threading. It's limited because, again, not all of the platforms like JavaScript supported, but there is reactive and coroutines. So coroutines do support, do exist in the common source set as well. For file IO, OKIO just folks at Square just announced that they released the first iteration of their file operations shared KMP library. You can check it out. There's also Kotlin X IO. I don't think it's yet been finalized, but it's definitely worth checking out. UI framework, Compose can do a good job if you really want to do it. So you can share part of your UI using Compose Desktop and Compose for Web. There are rumors about Compose native, means iOS, but again, for now, the focus is still on the business logic. Don't forget about it. And networking, of course, there is a KTOR client. So if you want to go and look it up, there is a KTOR framework, which is the backend framework, and there is a KTOR client, which is used for firing REST API and network requests. So KTOR client exists in the common main. It's quite powerful and useful. You don't need to go anywhere else. but you need to say goodbye to your old retrofit friends. And for datetime, again, thanks to JetBrains, they provide a datetime Kotlin X library. So as scary as it sounds, a lot of support is already done. A lot of common use cases already exist. But there is one more use case remaining. No test, no gist. If we cannot test our common code in a common way, then why would we even bother doing that? But don't worry. Again, Kotlin team already supported in a very minimal way, so don't expect too much from it. But if you want to add, if you want to write your test once and run it for all of the platforms, you can add the Kotlin test library, and it also supports iOS test. So just add it, and you will be good. One note about Kotlin native memory model. So I talked about threading is hard and is limited. Right now, Kotlin native memory model, which is the main blocker of the doing threading easily on the Kotlin native backend, is not the best, and it actually sucks. And the main reason is this exception will be seen quite a lot if you just get yourself involved into the Kotlin native threading. So you will see invalid mutability exception literally everywhere. But again, worry not, because JetBrains noticed it a long time ago, I think 1 year ago, and they are working, and it's actually already alpha. So definitely check it out. But you don't have to worry too much. If you want to get started with KMP and you don't want to deal with threading, don't worry. Just write your code in a comment, and don't even deal with the threading part until this memory model will be stable, which is going to be early next year. So as long as you don't touch the threading in the Kotlin native land, you're fine. You don't have to even worry about it. Everything is good and happy, but now it's about time that we use that module, the shared module that we created in other platforms. With Android, it was super easy because we have Gradle thanks to Android team, and we can just link different modules to our app module, and that's it. But with iOS, it's a little bit different. iOS has different mechanisms of building for it. You have to build a framework and then use it. I'm not going to go into very much details of how it works because there are other talks and it's a little bit out of scope, but just be aware that KMM plugin helps you a lot. You can also build the Cocoa pod, which there is an extension provided by Touch Labs, or Swift Package Manager, which is the latest and fanciest thing for iOS labs. All of those options are available, and you can just see which one fits your needs and is the easiest and pick it, because as far as I remember, there is not much differences in entry level, at least. The next one, if you want to build your app for a desktop and you're lucky enough to start your project with a Compose, so a Compose desktop already provides a small configuration block that if you just basically just copy paste this code and put it in your shared module build.gradle, you're fine. You will get packaging and publishing for free right out of the box. But here comes the tricky part, because it looks super good, but we have to talk about Greenfield and brownfield apps. And by that, I mean the apps that don't exist and you want to start it from ground up, they're called Greenfield. And the apps that already exist and you want to just migrate part of your features or subset of the app to the KMP, those are called brownfield apps. For Greenfield is fairly easy. As I've just showed you, you can just create a new module and just have the thinking of KMP, and you're good to go. You can write the code as much as possible in the common main, and with no extra cost, just share it with iOS labs or web developers. But when it comes to brownfield, the story is very much different because we will have concerns. The tooling. So right now, the tooling around KMP is pretty optimal. So we have Android Studio, we have IntelliJ, JetBrains is doing a great job at supporting and providing more tools to cover more use cases with KMP. So I think we are mostly sorted with tooling. And libraries, as I said, you're not alone anymore. A few years back, there was nothing in the in the common code, but now a lot of libraries exist and you don't have to deal with a lot of subtleties yourself. But here comes the elephant in the room. You have to convince other teams. And I cannot end this talk without talking about it because, again, introducing a new technology and also as a technology as this big is going to take some effort. So convincing the other team is actually quite hard, and I agree with that, but it's not impossible. It's doable. Some of the hints that I can give you to do it easier is to just talk with your teammates with a real proof of concept. So don't just bring out of this world example. Let's say your app is financial and then you want to demo KMP. Don't bring a to-do KMP app. Bring part of the app, the part of your own, your company's project into KMP and show how powerful KMP can work in those scenarios. Or and before you even talk about with your iOS friends or other uh, platforms friends, definitely have the code ready. Don't promise them anything. Have the code ready beforehand, spend the time, and then when you go talk to them, you have to be prepared, come up with the answer and show them the code they will see. The next one is also, again, going back to the real proof of concept, tackle those bottlenecks, those hard business logic that you have is the best place to start moving to KMP. Some of them can be maybe loggers, analytics, backend syncing, if you have a very crazy logic of syncing your data with backend, or even if it's small, it's still worth trying because that reduces a lot of load. Core business logics or networking, essentially all of the platforms have to implement networking. And if you move it to the share code, that means a code will not be written 3 times or 2 times. So these are just a few ideas that you can come up and take from your project and start to migrate it and have a sample code from them. The next one is definitely talk about other companies' experiences. And some of them are PlanGrid, Square with Cash App, and Kareem. They already moved their code to KMP and they all published some of their experiences with KMP. So Google it and you will see great talks on that. And you can benefit a lot in your company while migrating or suggesting KMP as a technology to your company. With that said, if you need samples, I have already 2 projects in mind. So I have Rion is the first one, which is my own project. It's open source, completely multi-platform. I think more than 80% of the code is shared between Android and iOS, although nothing is blocking us to go and share it with a web, but we still haven't done it. It's been released, the app has been released on Play Store, it's downloadable, and for iOS, we are working on it to release it. But other than our own app, we definitely check out People in Space, which is one of the best sources to get to know KMP from John O'Reilly, sorry, for butchering his name. No, I did not forget about. I did not forget about the promise I made. So we talk. I told you that I'm going to talk about the KMP can be used for or not. Yes, for me, KMP is much more useful than other platforms for all of the reasons that I already talked about. But also on top of that is the effort of introducing KMP to Greenfield is almost zero, because you just have to move your code and organize your code in a different way. That's it. And use different tools if you're already not using them. But for a brownfield, if you limit the scope, it is still not that big of a deal, because you're writing Kotlin, and if it fails, the code is still in Kotlin, which is the best language for Android, and you don't have to worry about, okay, I have a legacy code in there. No, the code is actually production ready, so you don't have to go and come back and revert back everything to normal Kotlin. There is no normal Kotlin; it's already there. With that said, welcome everyone to the new world. Happy Kotlining. Reach out to me with your questions if you have on Twitter. I'm happy to discuss anything with you regarding KMP. And if you're interested to work and come and work with me and other fellow Revolut lads, definitely check out our careers page. Have fun. Enjoy the rest of the conference, or probably the next day.